everyone! This video is another one in the ML Basics series, and this time we're going to talk about what exactly people mean when they talk about false positives or false negatives, or true positives or true negatives.
Let's say I show you 100 pictures and ask you to decide if there's a person or not in the picture. This is called binary classification because there are only two choices. There is a person or there isn't a person. And the percent of photos that you correctly classify is called the accuracy.
And we can further break this down into specific types of errors and correctness. Let's go through some examples. First up, you guess there is a person, which is correct. This is a true positive because there was a person in the picture and you guessed it. Second, you guess no person, which is also correct. This is a true negative because there wasn't a person and you guessed that there wasn't. Third, you guess that there is a person, but this is incorrect. This is a false positive. Positive because you guessed that there was a person, but false because there wasn't. And finally, you guess no person, which is incorrect. This is a false negative. Negative because you guessed that there wasn't a person, but false because there actually was.
Your overall accuracy is the number of true positives and true negatives that you got out of the total number of items that you classified. For example, if you classified 100 pictures as above with the people or no people example, and got 38 true positives, which means you correctly said that there were people in the picture, 32 true negatives, you correctly said that there were no people in the picture, 21 false positives, you incorrectly said that there were people in the picture, and 9 false negatives, you incorrectly said that there were no people in the picture. Your accuracy would be the number of true positives plus the number of true negatives over the total number of items you classified, which equals 38 plus 32 over 100, which is 0.7 or 70% accurate.
You may think that false positives and false negatives are not as useful as the true positives and true negatives that are used to calculate overall accuracy. But actually, these other metrics can give you really valuable insight into the specific failure modes of different models. For example, let's say we're designing a machine learning system that screens people for a disease. In this case, false negatives are much worse than false positives because we really don't want to miss people who do have the disease, but it's probably okay to have a few extra people who don't have the disease undergo further testing. The false negative rate is calculated by taking the number of false negatives over the total number of actual positives, which is represented by false negatives plus true positives.
An example where we might care more about false positives is in security. Let's say you have a smartphone that uses your fingerprint to unlock. It's fine if it doesn't recognize your fingerprint sometimes, but you really don't want it to accidentally open with someone else's fingerprint, which would be a false positive. You can calculate the false positive rate by taking the number of false positives over the total number of actual negatives, which is represented by false positives plus true negatives.
When you're dealing with false negative rates, you're basically asking, of all of the things that were actually positive, how many did I get wrong?
And when you're working with false positive rates, you're basically asking, of all the things that were actually negative, how many did I get wrong? Thanks for watching this video, guys. Leave us a like, a comment, or share or subscribe below. Bye.